Testing in production to me is about feedback. It's about putting like a little change out there and seeing how it behaves in production and watching it as it goes. There are tools and techniques that can be used to formally verify that software is completely correct to the specification. And those tools are really, really expensive, and almost nobody in the industry uses them. And so that sets the scene for this gradient. There's this gradient of correctness to what we actually do, and none of us is actually shooting for 100% correctness. We're aiming for confidence.
Hi, I'm Charity Majors.
And I'm Shelby Spees.
And you're listening to o11ycast, or o11ycast, a fortnightly series about the art and science of making production systems observable, easy to maintain, and appropriately reliable.
o11ycast is brought to you by Heavybit, a program dedicated to helping startups take their developer products to market. For more information, visit heavybit.com. If you're interested in being a guest on this show, or if you have a specific topic you'd like us to dive into, you can reach us on Twitter at o11ycast.
When you hear the words testing in production, what does that mean to you?
I think it means like giving up on the fiction of staging, or at least some aspect of that. Testing in production to me is about feedback. It's about putting like a little change out there and seeing how it behaves in production and watching it as it goes. And I think for a long time, a lot of people in software engineering, they would build their change and then they would hand it off to the ops team and that was it done. And I think, I really sort of leveled up in my career when I started following my change all the way through to users actually using it.
All the way out until users actually using it. Yes, your job is not done until you've watched someone use your code in production. I feel like this has been a more controversial topic than it perhaps should be, because so many people tend to hear when you say you should test in production, what they hear is you should only test in production. And it's like, no, we're not actually saying that. That would be insane. You should still do your unit tests and your integration tests and all the building blocks. What we're saying is that, like TDD, the most impactful software movement of my lifetime, no doubt, right? But they've made it impactful by discarding everything about reality, like everything that could ever be variable, concurrent, interesting. They're just like, doesn't exist, tra-la-la. And for a long time, you're right. It's like software engineers just kind of stopped there. And what we're saying is, no, your job's not done. Your job's not done until you actually make sure it works. And that has to mean production.
Yeah, I think the phrase test in production, I'm not really sure who sort of popularized using that term, but I guess it's similar to the hashtag no estimates sort of stuff, where the phrase is designed to be contentious, designed to make people that will sit up and listen.
I think I can speak to that because I started giving talks titled that. And the reason that I glommed onto that term was because of that wonderful meme, the I don't always test, but when I do, I test in production. And I was just like, it's so good. But I always meant it a little bit tongue-in-cheek, a little bit ironically. I feel like we have erred too far on the side of not paying attention to, almost treating production like an afterthought, which how? How do we do that?
Yeah, developers are so insulated from the reality of their code running and people actually using it that they no longer think about how to solve business problems and think about the user experience. They just think about these lines of code in front of me. And so it's just this very synthetic experience. And I feel like it's a loss both for the quality of our work as well as our enjoyment of that work.
Yeah.
It's so profoundly engaging to observe and experience your, the impact of your work in production, seeing how people actually use it, and then learning from it, that feedback loop. So I appreciate you bringing that up, Glenn, because that's I think the most important thing about testing in prod is we're already testing in production. Every time we deploy a change, it's a test. And so we might as well learn from the risks we're taking by pushing changes. Now's a really good time for you to introduce yourself, Glenn.
Yeah, Glenn. Who are you, Glenn?
Tell us.
Okay, hi. So I'm Glen Mailer. I make computers do things for people. Earlier in my career, I was really fortunate to land at a company called Skybet, where I learned a lot of things about dev, ops, agile, lean, security, and business. And after I left, I became a consultant where I tried to spread those lessons. But nowadays, I am a senior staff software engineer at CircleCI.
Nice. Talk to us about CircleCI. What are your philosophies around staging and testing there?
Yeah, so we don't have a staging environment, which it was one of those things. So I joined about 18 months ago now. And when I heard that, I was I was very surprised because you kind of get used to everywhere has a staging environment.
Yeah.
Everyone hates their staging environment. Everyone's like, I've got to go through staging. It's really expensive to maintain. It's always out of sync with production. Like it never really has the right data on there. Or maybe you've invested loads of money in this really fancy pipeline which copies data from production and then hides all the useful bits. And then, so it was a real breath of fresh air to find like they didn't have that staging environment. And I think that's been the way for a long time. Like the early founders are really big on sort of continuous deployment. And so, we merge a pull request and it goes to production. And then in order to make that safe, there's a lot of techniques and practices we have to do so we can test in production. And we do a lot of automated testing where we test pre-production as well.
Yeah, how do you do that? I don't know what the architecture of CircleCI is. Like, obviously, you have a bunch of customers who all have their CI pipeline, but are these do you have as many environments as you have customers?
No, so it's all big one shared thing, and I think that's a lot of how we can make it fast for customers is having this multi-tenant architecture. So the team I'm on is actually called the execution team, and in the term of executing a program.
Important to clarify.
Yes. So our Slack channel was called Executioners for a while, but we decided to soften it a little bit. But so we are the sort of the engine room, we're the team that's in charge of the infrastructure that takes care of running those builds. And so it's primarily a lot of pretty big boxes running on AWS where we cram people's builds in there, and then we can run with a bit of headroom in our scaling, so we can sort of bin pack all these jobs, which means they can start really, really quickly.
I assume that it isn't a big bang where everybody gets the same new build at once.
Sometimes. We still do that, but
really,
it depends what the change is. But it depends what you mean by at once, I suppose.
Do you do rolling deploys or canaries or anything like that?
Yeah, so the way our pipeline is set up is we try and minimize the time between commit and in the hands of customers, because I think the longer you're in that sort of middle state, the more you have to think about it.
Oh my God, yes. What is your average number of minutes typically for a change to go out?
So I think our slowest repository, it's about maybe 8 minutes between commit and the deploy starting. And then I think that rolls over the course of about 5 or 10 minutes.
Nice. Well done.
The fastest one is probably about maybe a minute or so to run all the tests, because we can parallelize as large as we want. We've got the bigger CircleCI plan, which is nice. So we really sort of go wide and sort of shallow with the pipeline, so we can get to the end quickly.
That's fantastic.
And then some of them, the roll will happen over the course of a minute or so if we're confident enough in the change. And we've got a few different levers we can apply. So when we're doing a change, we can say, okay, right, just do a fast roll, or actually, we think this change needs a bit more thinking about. So we'll launch a new version of the software into production alongside the existing version and check in our sort of monitoring, how does that differ from the existing software? Or we can go a bit more sort of heavyweight than that and say, okay, let's put some feature toggles in our code, let's ship that out to everyone but dormant, and then let's take our time over a couple of weeks gradually ramping that up to customers or opting in certain customers. Or sometimes what we'll end up doing is, as we roll it out percentage, because basically CircleCI's product is RG code execution as a service. So our surface area that's exposed to customers includes the Linux kernel. And we've got I don't know, I should have looked this up beforehand, but we've got many thousands of customers. And often when you upgrade the infrastructure, some really subtle thing breaks one or two people.
Yeah.
So being able to keep ramping up that percentage rollout, but just exclude a few people until you figure out what's going on with them can be really effective.
Yeah. This is so interesting. We're a customer of CircleCI, by the way. We're really happy with it. But build companies have been some of our earliest and best customers because you have this characteristic of, chaos, right? Your customers are all little chaos monkeys who all have these very specific, environments and pipelines, and they're all different. And it's really hard, I got to imagine, to ship a build that works for everyone.
Yeah, and this is something. So I think before my time, we had the 1.0 version of CircleCI, which it tried to use inference. So it would just look at your Git repo and guess what build steps you wanted. And then it would run, it had the same environment for every single build. And that we just install 10, 20 different versions of every bit of software, and you'd have to pick which ones.
Yeah.
And then when we upgraded it, we'd upgrade it for everyone at once. And so also before my time, but some people worked on the 2.0 version of our platform, which was very much about letting the customer pick what they wanted to do and what to fix and what to flex and what sort of base container to run builds in. And I think that's one of the things that allows us to make changes, is that each thing we change could be for a subset of customers at any one time.
Yeah. It's the original high cardinality problem where without observability, what a nightmare to track down these long tail problems. I feel the first time that I ever used canaries in a way that wasn't just by hand where you're like deploying to one host at a time, and just like the first time that I used in a more programmatic way was when we were doing the rewriting the API from using like Ruby on Rails to using Golang. And so like every day we're shipping changes that shouldn't break, right? That shouldn't change anything. And God, the types, like, cause Ruby would just like guess and assign types and like write them into the fucking database, and then like Go comes along and goes, no, and we've got mobile apps out there who can only be updated by hand every few months. And so they, you have to get all the types right and all the data every ordering nightmare, right? And so we wrote some stuff to basically let us fork the output, so that any request that came in, we'd send it to an API server that would actually fork it to an API server that was written in Ruby and one that was written in Go, and then we would diff the outputs and like write any differences out to a file, and then send the Ruby result back to the user. And then once a day, an engineer would log in and look at the file, just like which API requests are sending us different results, right? And we got really good at just programmatically like doing some of these things. And this is what I think that people forget when we talk about testing in production too, is we're not actually just talking about, well, everyone gets the new changes immediately, because that would be insanity, right? Like they're right. It would be terrible. But there are so many tools and knobs that, you have to invest in it. But like my argument has always been, you need to be investing into your ability to change production a little bit at a time for a few people at a time for like controlled, just controlling that burn.
Reduce the blast radius.
The blast radius, exactly. Because we all have a limited number of development cycles. It's like the scarcest resource in our universe. And so many people are just sending all of these resources into like trying to get staging right. And so they don't have anything left over to invest in production. And my argument has never been that nobody should have staging. There are some very legitimate arguments in industries who need staging environments. My argument is that the bulk of their resources should go into production, and then staging should get what's left over, not the reverse.
I can't tell you how many times I've had something work perfectly fine in production, but because it was the way we had to roll out changes, especially on the configuration side and the infrastructure side, it worked great in production. And then we found out that it was like buggy in QA or in staging. And then I had to spend all these like cycles.
Or vice versa.
Yes.
And it's just like total time sink, like for every engineering team, just the difference between the two.
Yeah. And when I think about these things, I like to put my sort of like product business hat on and be saying, okay, like there are tools and techniques that can be used to formally verify that software is completely correct to the specification. And then, you spend all your time making sure the specification's right. And those tools are really, really expensive, and almost nobody in the industry uses them. And so that effectively, that sets the scene for there is this gradient. There's this gradient of correctness to what we actually do. And none of us is actually shooting for 100% correctness. We're aiming for confidence.
Right.
How much time do we want to spend making sure this is right versus then putting it out there and being confident enough that this is a net positive change we're making? So how much does it cost to create a staging environment? How much does it cost to maintain a staging environment? Where could that money go? Like, where could that time go? And I think there's some really interesting stuff when you start testing in production. You sort of flex that muscle of getting that feedback from production that has some amazing, really sort of network effects that sort of knock on virtuous cycles. And then when you look at the research from the Accelerate sort of DORA people, they were saying these elite performers who are just pulling away from the rest of the pack.
Those are the teams that are investing in production. I guarantee you.
Exactly.
Absolutely. And it's not any one tool. It's not, there's like a suite of tools and techniques and everything. And like we were just talking about this, I think in our last recording, like I firmly believe that if you're asking an engineer to really change something about the way they work, to adopt a different tool, a different technique or something, it has to be an order of magnitude better than what they have in order for it to be worth, training everyone, changing. Like change has a lot of costs, right? It's very costly. All the unexpected things that happened, whatever. Like it has to be an order of magnitude better for me to confidently say, yes, this is worth your time. And I feel like the whole testing in production, reducing that amount of time between when you write the code and when it's live and users are using it, like that is, I think, for everyone out there, it is now an order of magnitude better. Like 2, 3, 4 years ago, I don't think it was. Even when we started Honeycomb, I think it was like maybe twice as good, maybe 3 times as good. So you've got some people who will adopt it. Some people who, I couldn't confidently say that everyone needed observability because it honestly wasn't, But now I think you're absolutely right. That percentage of teams that are elite, that are just like reaching escape velocity because they're so much better than everyone. Those are the teams that are investing in exactly this.
Mm-hmm.
Yeah, and it's that whole thing about the future's not evenly distributed, right? So I was fortunate enough really early in my career, before I picked up a bunch of bad habits, I was exposed to some of these ideas, and they've sort of been there at the back of my mind through a number of jobs in different aspects. And then so the last couple of years, it's really all come together.
As the tools have been kind of been maturing to meet them. Yeah.
I really love that Circle sort of necessarily dog foods your own platform and your own tooling the way Honeycomb does. I almost think it's like a requirement to build like a great product is you have to use it and you have to love using it and really care about it.
And especially for developer tools, I think that it's not a coincidence that so many of us, we've all just gotten stuck into our heads, and we all, meaning the industry, that building software and support it just has to be miserable. It just has to be awful and shitty, and we'll bitch about it and complain about it. And that's just the way it is. There's nothing you can do about it. And there are so many things that are bad about this. Anyone who's over the age of 30 doesn't want to get woken up all the time. Anyone who has kids, just like, oh my God, there are so many terrible, side effects for this. But I think that what CircleCI and Honeycomb and other teams are showing is that this can be a humane industry after all, but you really do have to radically rethink your socio-technical systems kind of from the ground up. And there isn't a recipe book. You can't just stamp it out because each one of these systems is a snowflake. Every single one of them is unique. You have your own business requirements and your own customer thresholds. What is painful for your customers is not the same as what is painful for my customers. And there's no substitute for actually understanding what you're trying to do.
Yeah, I think the thing you said there about each system being different, I think that's really key to me. Like, I am allergic to the phrase best practice. There is no such thing as a best practice. There are practices that work in context, and there are costs and there are benefits. Everything is a trade-off. That's not particularly useful, but it's more of a truism, I think. And yeah, I think this sort of dog fooding, this using our own product, like, it's really, really beneficial, especially for that feedback loop. There's some really interesting sort of occasional downsides of that. Like, for instance, if we have an outage, especially when it's down to like one of our suppliers that we're connected to, like, hug ops to them. But then we're like, okay, well, there are things we can do to try and mitigate the impact, but currently we're down. So we need to make sure we've got break glass procedures in place, or we'll have a version of our enterprise product deployed on the side that we can then connect up to our sort of productions, ship stuff out. So that's a really interesting thing. And the other one, which it's kind of a thing where when you work on a product day in, day out, and you know how it works, you get used to a certain quirks of it. And then there's this delta happens between the way we use our product and the way a lot of our customers use our product. Like, I spend all of my time thinking about CI.
Yeah. Like,
I do a lot of builds a day. I'm looking at that pipeline. I'm saying, how long is this going to take? I don't want to wait for it. I'm going to spend time optimizing it. I know all of my product features, so I know how to optimize it.
Yeah.
Whereas some of our customers, they will take 15 minutes, 20 minutes to run a deployment, and that's okay for them. But it means that our product, we can't just myopically focus on us. We can't build it only for us. We have to go out. We have to do that user research. We have to go out there and talk to people and make sure that the things we're building work for them as well as working for us.
Yeah, totally. Just sort of meeting people where they're at and making sure that you keep in mind that, like, we are always, maybe not always, but we're likely to be sort of the most sophisticated or the most knowledgeable users of the tool we're building, and making sure we step back and look through other people's eyes and observe like their experiences, and understand like the context they're coming from, where I'm like, okay, like, here's my side project. I want to build something. So wait, how do I configure the build config again? Like, how does that work? And I think about it once and I never think about it again. And, I deploy once a week on like a weekend or whatever, just whenever I make a change on is like my side project, it's not going to be something I optimize all the time, and that's okay. But also, like, how do we help people like that? And how do we also help people who are deploying like 50 times a day, like you probably are?
Yeah, this is the thing, like, from where I'm sitting, I can see all of these builds. I can look at them, I can inspect them, I can see the trends, I can see the aggregates, I can drill down with high cardinality and go, okay, what's the median build time? What's the P95 build time? Mm-hmm. But when you're at your company doing your builds, you have no frame of reference. All you can see is your build. And this is something we're trying to figure out a way of doing. Like, it's a very careful balance because we're in a position of high trust with our customers. Like, they trust us to run their sensitive materials. So we don't want to go poking around in their builds and, like, certainly not telling everyone else what's going on. Mm-hmm. But so I think we published like a data-driven report like maybe last year, where we took the sort of aggregate information, those percentiles, and said, hey, look, like, I think something like our 50th percentile build time is like 3 minutes. That might not be accurate. Like, read the report to double check me on that. But those sorts of like insights and comparisons is something that's really interesting.
Yeah. When your customers are developers, And this is a thing that we ran into at Parse is, we were running, mobile backend as a service, running databases for people, and it was a crazy business model, right? But like, I was constantly complaining about our customers, like, can you believe this query they're running? It's doing a 5x full table scan, just like motherfuckers, But in reality, we weren't surfacing that to people. They were just using the SDKs, trying to like make something that worked. They had no visibility into how they were abusing my poor database, and I feel like you can only hold people accountable for them insofar as you give them the tools to understand the consequences of what they're doing. And code is such a powerful tool that it's very easy to do terrible things.
Mm-hmm. Oh yeah. So this anecdote might be a bit niche, so maybe it won't make the final edit. But a little while ago, I think Ubuntu and AWS agreed to change their Kernel LTS policy. And the net result of that was we released an image which should have had a pinned major kernel version and did not actually have a pinned major kernel version. So there's a major kernel version upgrade. And we're like, oh no, we've upgraded the major kernel. Like, oops, what's going to happen? And actually almost nothing happened. Like the majority of builds were fine. That's why it got through canary testing. That's why it got to like the level of rollout it did, because everything looked fine.
Wow.
And then we start to get these Zendesk tickets trickling in of people saying, oh, I'm getting out of memory errors that I wasn't getting before. I'm like, oh, that's strange. So we look at one of the builds without memory error and we see, yes, that is using too much memory. That is correct. You're getting killed by the kernel. That's what's supposed to happen. So then I spent like a couple of days combing through the kernel change logs, trying to understand what had changed. And there was this ridiculously subtle behavioral change where I think basically somebody had looked at the kernel and gone, this is a really weird heuristic. Let's remove it. And the heuristic in question was, if you are a process and you have some child processes, and your parent process is using too much memory, we will kill a child first. And someone saw that and went, well, that's ridiculous. Why would anybody want that? And it turns out the Android build system benefits greatly from that optimization. So when you use too much memory, you don't actually blow the limit. And yeah.
That's amazing.
Just being able to like identify, these are the customers, here's the commonality, like here we can reproduce that.
Yeah.
And then, we eventually went back to the old kernel version and said that was too strange.
This is one of those areas where like observability, and by that I mean the technical definition of observability, which I will preach till I die, right? But like the ability, what it lets you do is it lets you say, these things are weird. What do they have in common? You can't fucking do that when you have a monitoring tool, right? You need to have those arbitrarily wide structured data blobs, one per, request per service, and they all need to be high cardinality, and they all need to, high dimensionality and all this stuff, because otherwise, like trying to stitch together that sort of narrative when you're just like spewing logs the old-fashioned way is almost impossible. And trying to do it with metrics is literally impossible because you discarded all of that connective tissue of the event at the time that you wrote them out, right? Like, and this is kind of a constant struggle for us, is like, I don't want to spend all the time lecturing people about why their monitoring tool doesn't do observability and why, their data formats aren't correct and everything. Like, that's really obnoxious. I feel like we need to find it as a different set of language that is more focused around, here are the things you can do.
Yeah.
And if your tool doesn't like meet the bar of can you do these things, then it isn't observability. Like, I feel like that might be a little bit friendlier.
Yeah, I think I've had a similar sort of scenario when you're trying to explain like the way a tool works to someone, and you sort of go through, okay, which ecosystem are you from? Do you know Ruby, Python, JavaScript? Okay, well, here is the tool you've heard of that's most similar to this.
Right.
And it's like Shelby was saying earlier, trying to meet people where they're at. And I think, so one thing I've been saying, so we have like this internal observability group at Circle where we sort of evangelize these concepts to people who are less familiar with it. And as I said, like, I was really fortunate. So back in like 2012, I was working at a place where we were doing structured logging. And then we had a process which tailed the structured log, parsed them, and produced metrics. So when you say to me, metrics are just derived logs, I'm like, yeah, of course they are. What else would they be?
Yeah.
Like that just fits straight away. And so what I've been saying to people mostly is like, these wide events that you talk a lot about are just good logs.
Yeah.
And most people have not seen good logs, so they don't know what good logs look like.
Mm-hmm. Right.
And that's the way I've been trying to sell it, which I guess it makes it sound more similar than it is. But like, no, they're really, really good logs.
They're really, really good logs.
Yeah. What made it really click for me, and what I've been trying to help when I help people connect the dots there, is like sending disparate pieces of information that you're trying to like get it to match up later on, versus like sending your context up front as this blob that you can then slice and dice later on. And with metrics and with traditional like flat logs, it's very expensive within even the same method to like connect the dots between a log line that you're sending at the beginning of that method method in at the end when it's successful or something like that. Versus like with your contextual events, that's already in the event that you're sending. And so then it's just better structured data.
It's hard to describe.
Yeah, maybe I just described it like in a more confusing way, but that's like, it's when I've explained to people like this, like sending it up front as like a unit versus like trying to glue it back together later on, it just makes so much more sense.
Well, the thing that helps me describe it sometimes is reminding people that this all became very much more mandatory when we started having microservices. Because with the monolith, if you really wanted to understand what was going on, you would just trace it, right? But now it hops the network, which means that whole model is just broke. You can't attach GDB to it now, right? And so you have to have a way of passing all that context around with the process as it hops around. So it's really kind of more like applying GDB to your systems, right? And it's just your responsibility to pack all that context together to ship along with the request as it goes bouncing around.
And this is actually really interesting to me because I'm not going to disagree with that, but I'm going to say something slightly different, which is, I think when I first started hearing about Honeycomb and reading about Honeycomb, I think it might have even been before you had the trace waterfall implementation. And it's before everyone like tracing. And it feels like the tracing was the thing that really made people go, oh, okay, now I see it.
Yeah.
And tracing, those trace waterfall graphs have this really visceral, you're like, my code is doing what?
Yeah, yeah.
And we get so much of that.
The time is going where?
But I think once you've got over that initial hurdle of tidying up those traces, then actually that trace waterfall becomes way less useful.
Yeah.
Not because it's not showing you information, but because like you're not doing such weird things anymore.
It's only useful to you when you know what to look for or where to find it, right?
Yeah.
And this is where like we versus Lightstep, like we're very similar, but we've heard it described as, Lightstep is tracing first and then high cardinality events. And Honeycomb is high cardinality events first and then tracing, which I think, as I would, is the correct way to approach it, because it's always about, trying to figure out what's wrong, and then you want to trace it to see what's wrong about it. But finding the thing that's the place in your system that has the code that you need to debug is the entry point. That is usually that's the hardest part and it's the place to start.
And our adoption of Honeycomb at CircleCI, like anyone's adoption of any tool, I think is incremental and it's driven by need. And what I've actually found in we've got a few of our services which are not really connected up to that big trace graph, but they do emit a single wide event per request. And I can get so much out of just that without connecting the tracing to anything.
Yeah.
And I think especially when the tracing bits we've got around people running builds.
Yeah.
I have I have two events for every build that runs. I have an event when it starts that tells me how long it queued for and what the aspects of it were. And I have an event when it finished, which tells me which node it ran on, what version of the kernel was there, how long it was waiting, what it was connected to, what type of executor it's on. And just from those two events, I can get so much value. And so one thing we're grappling a lot with at the moment is dynamic sampling. So we have a lot of data. I think our raw logging system is in the terabytes a week. That's very expensive. We don't want to spend that money. We want to keep the signal, we want to lose the noise. But there's this visceral emotional attachment to my data. It's no, I did some work. Don't let me throw away my logs. I want to see it. And the thing I really like about those wide events, especially for running a build, is that's the thing we bill our customers for, is running builds. So I can say, I'm charging someone this much and I'm storing 2 events. I can definitely afford 2 events per build.
Right.
So I can 100% sample those. But when you start talking about, okay, well, we don't bill for use of our API. So if someone calls our API a million times a week, how much of that can I afford to keep?
Right.
How much of that am I willing to afford to keep?
Those wide events also, in a way, help replace the need for staging. Because if you can see, these 300 or 400 attributes are the context in which this job was executing, that often tells you everything you need to know about how to reproduce it, right? You don't actually have to go reproduce it. You can just see, these are the outlier things. These are what all the errors have in common. Secondly, I love that you said that, because I have increasingly been thinking that another differentiator between the sort of infrastructure monitoring sort of thing, your Datadogs, your SignalFXs, your Wavefronts versus observability tools, is that metrics are the correct tool to use for infrastructure, right? Because you care about provisioning, you care about capacity, you care about, do I need to spin up more of these because am I running out of some resource? And there's been kind of this division between dev and ops, where dev is responsible for the code, ops is responsible for making the services that the code runs on. And infrastructure is the code that you run that you don't want to have to run, but you have to run in order to get to the code that you want to run, right? and I feel like observability is the right tool that you need for the code that you are writing that is your business. It is your differentiators. It is the stuff that you're changing constantly efficiently. It is the stuff that your users are interacting with. It's the stuff where you don't care about in aggregate and all the stuff you care about. Each and every request needs to succeed, right? And can it get the resources that it needs or not? And we found that, the thing that most predicts whether or not a company is a good customer of Honeycomb or not is, do they have dollar values attached to the quality of their service, right? If they're like a media company that's just like ads, they're just spraying ads everywhere, they don't actually give a fuck whether or not a particular user sees an ad at a given time, they're not a good customer for us. If you have dollar numbers attached to, like, if you're a delivery company, for example, or a CI/CD company or something, you actually care about every single one of those jobs needs to be able to run for something that's not our fault, at least, right? Then you need something like observability. And I feel like it's interesting. I've been thinking about this and realizing what an enormous percentage of the engineering at every single tech company goes to not their core business differentiators. Right? Even for like the software engineers, so much of it goes into, writing the libraries or just getting the stuff to make it so that a few of them can work on software that is actually what their customers are paying for.
It's like teams full of like yak shaving, right? Just like, yeah.
Even at Honeycomb, like we've had like 9 or 10 people writing code for the past year for all of it, right? The storage engine up to the UI, UX integrations. We had 9 or 10 people, and we've been making about 1 or 2 engineers worth of progress on our core business objections every 8th. And we're incredibly high performing, right? And like serverless is like the only example of, I think, I hate this about them, that they're always like, less ops. I'm like, no, you motherfuckers. You're doing ops better.
Less infrastructure.
You're doing less infrastructure because you've successfully created the right level of abstraction to make most of your ops somebody else's problem. It doesn't mean that there's less ops. It means that it's being done better and probably not by you.
So I see this a lot in people I interact with the term SRE, where the terms like sysadmin, ops, infrastructure engineer, platform engineering, SRE, DevOps, they all just kind of get glommed into one.
Yeah.
But there's a lot of different disciplines within that.
Yes.
And I started my life as a dev, and then I worked in some ops teams as well, where the people sitting next to me literally had the job title sysadmin, and we were in a DevOps team, which apparently you shouldn't do. But I've seen it work really, really well if you get it right. But one of my colleagues at the time, I think we were learning about the DevOps movement. We were a PHP shop at the time, so we were looking at Etsy a lot to hear what they were saying, and Etsy were putting out some really good stuff around that time. And I don't know who coined it, but someone once said to me that DevOps is ops, but measured on business outcomes. In the same way that sort of like you don't generally measure devs on like lines of code or code coverage. You measure on like, are they moving the business metric? I think on a recent cast, you were talking about value stream mapping. Like, how does the work we do actually map to the outcomes of the business?
I love that.
And in the bad old days, we had the ops team was measured on uptime, and the dev team was measured on new features. And so one team wanted to change, one team didn't want to change.
Yeah.
And I think, to me, the best framing of DevOps I saw was, we're going to take the ops team and we're going to measure them on business outcomes. So now they're incentivized to promote change. And if they're incentivized to promote change, incentivized to make change safer, more continuous, smaller.
I love that. I just wrote this very long essay about this, about how infrastructure and operations used to be synonymous, and they've been increasingly diverging around this fault line of infrastructure. And if you want to do infrastructure, God bless, go join a company where infrastructure is their mission, right? There's still a lot of work for people who have expertise in ops to do, but their expertise is increasingly in joining a company and helping them figure out how to make as much infrastructure and ops stuff someone else's problem. Because it turns out this is a really challenging and difficult and sticky and hard and fun set of problems, right? Like figuring out how to ship software efficiently is like just mind-blowingly challenging and interesting and intricate. And it's really hard to do unless you have a very strong grounding in what has traditionally been called ops or DevOps or infrastructure.
For many years, I used to have a post-it on my desk at all times that said, it's probably disk space. And I haven't had to think about disks for about 5 years now.
Or the network. It's probably the network's fault. Yeah.
It's always DNS, right?
Yeah. And it's great. It's liberating. But there's a certain amount of mastery that you have to get in order to help teams actually level up and improve at this stuff.
I think there's an important space there for just helping developers. This happened to my friend who's very much like a backend developer, never touched infrastructure, doesn't know how to spin up an EC2 instance or whatever, but lives in production. And he got he sent me a screenshot of this recruiter email that was like, you're an expert in SRE and stuff like that. And I was like, okay, well, you might not have lots of experience with the SRE title, but you've been living in production for years and years, and you've gone out of your way to make your services more reliable. And I think learning the domain of what is infrastructure and what is ops, and like you said, Charity, like we don't want to be thinking about infrastructure, but we want to be thinking about operating our systems and making them available and reliable. And I think you've even said before, like the next 10 years of DevOps is teaching devs how to live in production. And so I think that's like the convergence of like everything that's happening right now is help devs live in production and break down those walls. And you will have not only DevOps teams and SREs with a sysadmin background who really care about making your services reliable, but also you'll have developers thinking about how do we reduce infrastructure costs? How do we reduce spending on third-party tools? How do we make our code more efficient so that like we can exchange that for more business value, things like that.
My favorite website on the internet is who-owns-your-reliability.com.
I guess it says you, right?
You do.
Yeah.
All right. I think that we're about out of time here, but this was super fun. Thank you so much for coming, Glen.
Yeah, thank you so much.
Thank you for having me.
That was a delightful conversation that I enjoyed and hope you did too. If you're interested in being a guest in this show, or if you have a specific topic you'd like us to dive into, you can reach us on Twitter at o11ycast.
To learn more about Heavybit, visit heavybit.com. And while you're there, check out their library. It's packed with amazing talks on sales, marketing, product, and general management from founders of developer tools companies and other industry leaders. Hope to see you next time.